All right, so we draw a straight line L, that's our green line. We label points A, B, C, and D on that line. And then we need to show that the slope between A and B is the same as the slope between C and D. I don't love this problem. B, draw the rise and run for the slope between points A and B. Label the intersections as point E. Draw the rise and run for points C and D. Label it F. Okay, so, and then if we read along later, it looks like AE is supposed to be a horizontal line. So we're going to do between A and B. Yes. Okay, so between A and B, so I'm just going to sketch this so that between A and B, and this point right here is going to be E. And then from C to D, from C to D, which this is not how I would normally set it up. I had to read ahead to see that those lines are supposed to be horizontal, horizontal. Okay, so in D we read that AE and CF are both horizontal lines, so they're parallel. Originally, I drew them differently, so AE was actually vertical. Anyway, it doesn't matter. So we are, the slope between A and B, the slope between A and B is a ratio of BE, that's our rise, BE is our rise, our run is AE, so that's the first box. The slope between C and D, our rise is DF, and our run is CF. Okay. We could extend CF and AE. I guess we'll do that. If we look at that, these are both parallel lines, right? I'm going to try and not cut through my stuff. These are parallel lines. They're both horizontal lines, so they're parallel. So we can extend them out like that. And we know angles in parallel lines. We know that angle A right here and angle C right here, I guess angle EAB and angle FCD are corresponding angles. And so they're the same. And therefore, and also we know if we were to, I guess, extend, are we supposed to do that too? I don't think so. Anyway, so we have similar triangles. This angle right here is 90 degrees. This angle right here is supposed to be 90 degrees if I drew it straight. So we have two angles that are common. We know that if we have two angles that are common, we have three angles that are common, so they're similar triangles. Let's see, what else? Okay, did that. Complete the following statement. BAE, BAE, and BEA. Oh. BAE and DCF are corresponding angles and are congruent. The angles are congruent. BEA, so BEA and DFC are right angles and are congruent. By angle similarity, triangle ABE and triangles CDF are similar triangles. Use the fact that the lengths of corresponding sides are similar. Triangles are proportional to complete the following ratios. BE is proportional to DF. So BE, which we have right here, right? We have BE corresponds to AE. So BE and DF are corresponding. And that means that we're going to equal AE to CF. because those are the sides that correspond to each other. And we can write the proportion so that the ratios compare parts of the same triangle, which is what we wrote right here, BE over AE and DF over CF. So we can write those as equal to each other. BE over AE is equal to DF over CF. The proportion you wrote in step H shows that the ratios you wrote in C are equal, so the slope of the line L is constant. Because these ratios are equal, our slope is the same. The ratios are the same. And so because the ratios are the same, that represents the slope, and the slope is the same. I feel like this is a very convoluted, complex, I think would probably be a good word, complex way to try and show this. I'm not too worried about you being able to go through all of these steps, but here they are, just if you needed them. And let's look at the reflect. What if, suppose that you label two other points on the line L as G and H. Would the slope between these 2 points be different than the slope you found in the Explore activity explained? No, any 2 points on that line. The thing is, that line is constant. The slope doesn't change. If it was a changing slope, then it wouldn't be a straight line. And so I don't even really want to go into that anymore. But no, the slope would be the same. If we were to make more triangles with more points, the ratios would still be the same. So the slopes would be the same. All right, I think that's good for this video.